I have here a scanner which I'm going to try and repair. It's a LED based scanner, and actually the LEDs are quite bright. You can see if I just zoom in here the LED assemblies. Now I've plugged this in to the control unit and found that only one of the LEDs seems to be illuminating. So to troubleshoot that, the first thing that I wanted to do is to identify the wire that leads from the LED which is working, and it's the end one connected to this white wire here. Now these connectors are quite easy to remove from the connector block here by pushing with a small screwdriver the small metal tab on here inwards and then pulling the wire out. Now why do I want to do that? Because what I did was I took all of these connectors out and put the white wire, which is connected to the working LED, into each of the other positions in turn, and I found that no matter which position the white wire was in, that LED works. So that tells me that the control unit, the drivers, the output drives of the control unit are all good, and that one LED is good, but it seems that all of the remaining 7 LEDs appear to have failed. The next step is to remove this cable protection plastic sheath, enabling us to get access to the individual wires, and someone suggested there might be a ground fault to the unit, but there doesn't appear to be. All of the LEDs are grounded to the metal case, and all of these individual wires are connected through to the connector that goes into the control unit. So there's no grounding issue on this. It does appear to be the LEDs that are bad. So what we're going to do now is to remove the lens, the plastic lens from the front of the unit, and try to remove the individual LEDs. Okay, so there's a clear piece of Perspex and a yellow tinted piece of Perspex, which are sitting one on top of the other. Not quite sure why, maybe just to make up the width to make it fit the frame. So what we're going to do now is we're going to go ahead and try to remove the individual LED assemblies from the light bar. The 6 LEDs in the middle, that is excluding the end ones, have 2 screws which just hold the LED assembly and the heatsink to the frame of the light bar. The end ones also have a connection, and I've removed this one already, look. They also have a bare wire connected to them, which is a ground wire and connects to the case. I'm not quite sure why that's done, because the light bar itself is grounded to the bodywork of the car, and the frame is going to be all grounded, so I don't know why we have a connection from the ground connection on one LED at that end to the ground connection on this LED at the other end. But anyway, we'll put it back when we do it. So what we're going to do now is to go ahead and remove each of these LEDs by undoing these 2 screws that hold each of the individual LED assemblies into position. And in fact, I'm also going to remove this nut at one end of the light bar to make it easier to access the screws on this end one, and to remove the LEDs themselves. That is actually secured on the other side by a screw, a cross-point screw, which you might be able to see down there. So you may have to hold that screw to release this nut, or at least to tighten it back up again. Okay, so now that I've removed this end LED, I can see a bit clearer what's going on now. That screw that has the crimp connected to it is connected to this thicker black wire, which doesn't go down the main harness to the control unit. That goes to this this loose lead, which is going to be grounded to the bodywork of the car. Now the interesting thing is that bare wire, which is connected to the LED at the other end, doesn't appear to go anywhere. It goes into the harness, which has the other 8 insulated wires, but it doesn't come out the other end. So I'm not sure what the purpose of that is. It seems completely pointless to me, but you know, we'll reconnect it when we're done, because, well, because it's there, so it must serve some purpose. So let's go ahead now that we've removed all the screws and remove the actual LED assemblies themselves. I'm going to go ahead and remove each of these cable ties, these little zip ties, so that it will enable me to pull the wire connecting to each LED forward and remove the LED itself and the little heatsink mounting on which it sits. So let's just do that. Okay, so those zip ties are removed, so I can now push each of these LEDs forward on its individual wire and bring them out the front. So now to pull these LEDs out, we can just pull them forward, and it's a bit of a tricky thing to get out. It looks at first like they won't come out, but what you have to do is kind of raise it, get the lower edge over the bottom lip, and then pull it down, and then you can pull the whole assembly forward, like that. Let's just do another one. So we pull it forward, and we lift it up so that the bottom edge goes over that lip, and then over and out. So we'll do that with all of them. And you'll see that now that I've pulled all of those out, my fingers are covered in a lovely white compound, which appears to be heatsink material compound, generally used to connect power transistors and the like to metal heat sinks. So I would assume that the heat sinking compound is smeared on between the LED body and these metal frames, heat sinks, to help dissipate the heat from the LEDs. However, it seems that there appears to be more of this heat-seeking compound plastered around these resistors, these current-limiting resistors, and those seem to be wired in a little bit of a strange way, because for each of the LEDs, the 12-volt power supply is on this side. Here, look, and then the negative side. These are marked plus and minus. So the negative side of the LED goes through a resistor and is then strapped to the frame of each of these LED mounts. What about the resistor value? Well, I wonder if those resistors are sufficiently high power rating. Now the question now is what these LEDs are. What is the part number? There doesn't appear to be any part number on the devices, so I'm going to have to search online and see if I can see anything similar. Okay, I struck lucky, I think. I've just been online and just did a quick search to find high power LEDs, and I found on Amazon, and I'll put this link in the description below, some devices which look like they're exactly the identical device that's used in the light bar here, made by a company called Chanson, which sounds remarkably Chinese, at £3.99 each. Now there are different ones that you'll find on this website, but these are the ones that we want, the 10 watts, one piece at £3.99. If you put the mouse over the others, you can see they look significantly different. 20 watt ones, they seem to have more LEDs in the device itself. 30 watt ones, 50 watt ones, 100 watt ones, but these look like the ones we want, with looks like 9 individual LEDs within the device. These other ones are packs of 10 very much smaller ones. So yes, these are the ones that we want, £3.99 each. So I'm going to go ahead and order 8 of those at £3.99. Let's call it £4. So that's going to be about £32 for the LEDs. I know we have one LED that's working, but we may as well change all of them, because whatever's caused 7 of them to fail may have damaged the 8th one as well. Let's look at this here. We seem to have some specification information here. Okay, so the one that we're interested in is the cool white one, by the look of it, which is the fourth one from the top, indicating a forward voltage of 9 to 11 volts. Well, that's interesting, because when I put the meter over it, it was reading like a diode volt drop of 0.7 volts. So let's assume that it does need that voltage to drive it. I'm assuming that the drives that come out of the control unit are about 12 volts as opposed to the battery voltage, which may go up to about 14 volts. And it's saying it needs probably about 840 to 1000 milliamps. If we look at the specification here, what does it say? It says 900 milliamps. So that's probably a happy middle ground between those two limits, and 9 volts to 11 volts. Okay, so let's assume that we want to drive it with 10 volts and it's going to pull 900 milliamps. So while we're waiting for those devices to arrive from Amazon, let's do a quick calculation as to what kind of resistor value we probably need to put in here. I'm going to assume then that we have a 12 volt supply to each of the LED modules, and as you can see, once the 12 volt supply goes to the positive side of these LED modules and then goes down through a resistor. So as we know from the specification, we have a 10 volt, nominally a 10 volt voltage drop across the LED module. So if we're supplying with 12 volts, we need to drop 2 volts across the resistor. And we need to allow 900 milliamps nominally through the LED module. So this resistor has got to drop 2 volts at 900 milliamps, or 0.9 of an amp. Now you'll remember from Ohm's law that resistance is actually the ratio of the voltage across a resistor to the current passing through it. So if we want to work out the resistance value, we've got 2 volts over 900 milliamps, which is 2 volts over 0.9 amps, which is about 2.4 ohms. Now I've measured these resistors and they do work out, they do read exactly 2.4 ohms. Actually I was reading 2.9 ohms on the meter, but then I realized that the resistance of the leads themselves was 0.5 of an ohm, so yes, the resistance values that are in there already are 2.4 ohms. However, let's work out the power rating that we need for those resistors. And the power rating, the power dissipated by the resistor, is going to be the voltage multiplied by the current, or 2 volts times 0.9 amps, which is 1.8 watts. So let's go nominally with 2 watt resistors. So we'll go ahead and order 8 of these as well. Now the resistors in here, these resistors that are fitted, I may be wrong, but they don't look like they're 2 watt resistors. They look physically too small to be 2 watt resistors. So we're going to order some which are definitely 2 watts. Yeah, and you can actually tell by the colour band on here that the value is as we thought. Red, yellow, black, and silver, I think. So that's 240, with a multiplier factor of the silver band putting at 2.4 ohms. Okay. I'm going to go ahead now and snip the wire from each of these LEDs, because we're going to have to resolder it to the new LEDs, and then remove the LED modules from these little heatsink frames. Alright, that's all of the LEDs removed from the heatsinks, and they're held on by a small screw on one side and a small screw and nut on the other side, and the nut holds the resistor down. Now be careful not to mix these screws up with the ones that hold the heatsink to the actual light bar. They are a different size. these ones that hold the frames to the light bar, as you can see, are a little bit wider, so keep those separate. I've just marked on the back of each of these LEDs for the owner's benefit, an X on all the ones which are bad, and a check or a tick on the back of the one LED which seems to be working, just in case for any reason you need to use that one again at a future date. I have actually received now the replacement LEDs. They took about a week from Amazon, which isn't bad, and you can see that they are the identical part to the originals. Here's an original one, and there's the replacement one, so it looks like we have definitely got the correct part. And of course we have 8 of those, so we're just waiting now on the 2-watt power resistors, and we can go ahead and try and put this back together. I just noticed something. Spot the difference. All of the ones which are not working have 6, 1, 2, 3, 4, 5, 6 plastic mounting studs to the frame, and the one that's working has only 4. I'm not sure what the significance of that is, if any, but yes, the one that's working is slightly different. Alright, so our 2.4 ohm 2-watt resistors have arrived from Farnell, and you can see that physically these are significantly larger than the ones that are fitted. The other thing that I've noticed, apart from the slight difference in the mounting of one of these LEDs, is that not all of these resistors are the same value. They're about 2 ohms, but the first one we looked at was red, yellow, black. This is red, red, black, so that's about 2 ohms as opposed to 2.4 ohms. And anyway, we're going to put 2.2 2-watt resistors in each one. And the trick now is to work out the best way of fitting these to the LEDs and making them not short to the case. So I'm going to go ahead and work out the best way of doing that, and watch this space. And looking at these new LEDs, they all have the 4 plastic mounting studs, meaning that they are similar physical construction to the good LED that didn't blow. I've also measured the forward volt drop of each of these new LEDs, and none of them seem to give a reading, so they actually all read as if they're open circuit. But that probably is in line with what we've seen on the spec sheet, in that the forward volt drop should be about 10 volts. So I don't know why that one which works is measuring 0.8 volts or 0.79 volts. Anyway, all we can do now is just go ahead and replace these resistors and LEDs and see what happens. Okay, plenty of heat sinking compound on there, and screwed it, you can see it's oozing out at the edge, look, and screwed it down to this metal heatsink to make sure it has good thermal conductivity, and any heat dissipated inside the LED assembly will be conducted away thermally via this heatsink and the light bar. So what I'm going to do now, what I've also done is I've bent up the 2 tabs, the 2 terminals at each end, to avoid any possibility of them touching the metal frame and shorting to ground. So we're now going to go away and we're now going to go ahead and put the resistor between here and the metal frame, and also connect each of the wires back up to the positive terminal, remembering to thread it through that back hole there. So I'm bending each of the resistors like this with a little hook to put around the screw, and bending it into this shape so that it can easily fit in. I'll show you now on this first one that we've done, so that you can see that the resistor is going between the negative terminal, soldered on there, and they're bent upwards so that they don't short. and the wire, the feed wire, is going through. So that's one of them done. All I have to do now is the remaining 8. Alright, so that's all of the new LEDs fitted into those heat sinks and fitted back onto the light bar, and cable ties refitted, and that little bolt refitted as well. So all that remains is to test it. You can share the experience. Okay, power on. This is the default scan pattern, and I'm now going to increase the speed. Okay. And we appear to have a working scanner. And it's pulling about an amp. Which makes sense, because if you look at the spec sheet it said 900 milliamps, 0.9 of an amp. So yeah, that's about right. Okay, so we're just playing with the different settings here, trying to find out what controls the speed. It looks like this less than arrow sign would slow it down. I press it several times. We've got a slower scan. And if I press the greater than arrow sign, we've got a faster scan. Now I'm just going to see if it keeps the scan speed when I power it down with the power button. So I'm going to power it off with the power button. That's this little power button, not the main one. This one right here. So off. And back on. And it seems to keep the faster scan speed. However, if I power it down with this main power button here, and leave it a few seconds and start it up again, then I've got to press power button again, and it seems that it's reverted to a default scan speed. So if you want to keep the scan speed, it seems you've got to keep the power on, the main power button, and just depower it with this little button here. We've got different modes as well by the look of it, but press this one here. That seems to do a 6 LED scan. I wonder if that's for like the pilot car, because I think it had 6, didn't it? That might be what that's for. Press it again, and we've got a scanning from centre outwards. Press it again, and we've got like 2 4 LED scanners going in the same direction. Again, and we've got another pattern. And again. And we've got a very slow scan. I think this is simulating a faulty car or a faulty kit, because the LED is doing the same thing, so it's not the light bar that's faulty. Press it again, and we're back to the standard 8 LED normal scan mode. And we can change the speed, as we said before, by that greater than arrow button on the control unit.
Interestingly though, Neil, if you set it to a faster scan speed,
yeah,
what happens if we then go...
It's gone off now.
Yeah, I think that's a timer. If you restart it again, the power button, we've got this faster scan speed. If you change the mode, does the mode also take the scan speed with it to the next pattern?
I'm not sure. It's gone off again.
Oh, that's interesting.
Maybe that's not the normal scanner. Maybe that's some kind of scanner which has gone, which is a timer. Maybe there's a scanner with a timer. There's a lot of maybes in this. It'd be interesting if we could find out an instruction manual from the manufacturer. I'm not sure who the manufacturer is of this unit.
So if we change modes now to a different mode,
Seems to,
so it does take the scan speed with it.
Yeah.
What about if we change mode again? So I wonder now if it times out like it did before. If we leave it on there a second.
I think that timeout mode is, I think it's one of the modes, is it times out. Maybe if you want to leave the scanner going into show, but only for a few seconds, and then switch itself off.
Yeah.
Which would make sense. You know, you set your car up at a show, you set the scanner going, and it's only going to go for a few minutes, so it doesn't kill your battery.
Yeah, it doesn't seem to time out on other patterns, does it?
No.
And one thing we did like on this is when it's got the trailing effect on the light bar. Hopefully the camera will pick it up, but it also does the same trailing effect.
Yeah.
Actually on the unit as well.
So that's gone off there. I think it's a built-in timer in one particular pattern.
And possibly the plus and minus buttons which we have here.
There's your 6 LED one.
Maybe they also alter the timer when you're on the other pattern.
I wonder if just powering it down and resetting it's always going to bring it back to the standard scan mode.
No, it retains.
And what about if we depower it and bring it back?
Then it goes back to its default.
Default mode and default rate.
Yeah. Okay, there we have it. One repaired scanner.